Solving Simultaneous Equations, Part 2. Before we begin this part proper, let's remind ourselves of the objectives we've set for this part of our studies. Number 1, be able to calculate the exact solution of two simultaneous equations when there are two unknowns, normally referred to as x and y. Number 2, be able to interpret equations as lines and the common solution as the point of intersection. And 3, be able to solve simultaneous equations in two unknowns, one equation being linear and the other being quadratic. What we will address in these sessions is solving simultaneous equations using the method of inspection, solving simultaneous equations using the method of algebraic elimination, solving simultaneous equations using a graphical method, and finally, last but not least, using what we've learned to set up and solve various problems using simultaneous equations. Previously, we've already discussed and worked through the method of inspection. So this session is going to focus on the algebraic elimination method. And the best way to do that is to look at some examples. But before we do that, let's remind ourselves something about algebraic elimination. This is the method we'll use most of the time to solve simultaneous equations. The idea is to multiply one or both of the equations we have by some suitable multiplier until we have matching numbers of x's or y's. Then we'll eliminate the x or the y to solve for the remaining unknown. We can use substitution to complete the solution. Example 1 is taken from page 120 in your textbook, with some modification for this presentation. Here's our two equations, 2x minus y equals 8 and x plus 3y equals 11. Now, as we previously stated in part 1 of our course, we decided we should be organized and give these labels. So we'll label these up 1 and 2, equation 1 and equation 2. A quick inspection shows us that the method of inspection will not be applicable here. So, instead, we make the x's match by multiplying through equation 2 by the number 2, and that would give us 2x plus 6y equals 22, and we'll call that equation 3. Or instead, we can make the y's match by multiplying through equation 1 by the multiplier 3, and that would give us 6x minus 3y equals 24, and we'll call that equation 4. Now, we shall try both ways using equation 3 or 4 to get rid of either the x's or the y's to show that we can get the same result either way. So here we are again with our two equations. Let's attempt to eliminate the x's first. So we're going to get the 2x plus 6y equals 22, which was equation 3 we previously developed. Now what we're going to do is subtract equation 1 from equation 3. Why that way around? Well, if you look at equation 3, there's more y's, 6y, compared with equation 1, only minus a y there. And if you look at the numbers on the right hand side, the number 22 is obviously bigger than the number 8. So it seems a safe bet to take 1 away from 3. Let's look at the left hand side then and the right hand side. On the left hand side we get 2x, take away 2x, plus 6y, and then take away a negative y. That's important. I've put the negative y in brackets so we don't forget there's two negatives involved here. And on the right hand side we get 22 take away 8. The two x's, the 2 plus and the 2 minus, knock each other out. Now we've got to be careful with this double negative on the y's, because two negatives and negative negative will give us a plus. So that negative negative y becomes a plus y. So we end up with 6y plus y equals 14. 22 take away 8 gives us 14. So 6y plus y gives us 7y. 7y is now 14. We can see that 7 is a factor of 14. We can divide through by 7 and we'll end up with y equals 2. So we solved the first part of the problem. We can now use substitution into equation 2, and I'm picking that because it looks the easier one of the equations to use, and substitute in the value of y. So let's do that. There's our equation 2. We're going to put in y equals 2, and we'll end up with x plus 3 times y gives us 6 equals 11. So if we subtract 6 from both sides, we'll get the x on its own. We'll get x equals 11 minus 6, or x equals 5. So we've solved our problem. We've got x equals 5 and y equals 2. Easy peasy. Now let's try the same solution but eliminating the y's rather than the x's. Now we should expect to get the same answer. There's our equation 1 and 2 as before, and this time I've added equation 4, the one we previously worked out, instead of equation 3. We shall use equation 4 by adding equations 2 and 4 together. Let's look at the left hand side and the right hand side of our equations again. We get x plus 6x plus 3y minus 3y equals 24 plus 11. The 3y's will knock each other out, the plus 3y and the negative 3y will knock each other out, and we're left with x plus 6x on the left and 24 plus 11 on the right, which will give us 7x equals 35. 7 is a common factor of 35, so divide through both sides by 7 and we get x equals 5. The same solution we got last time for x. Now we need to do a bit of substitution. We'll take the value for x, which is 5, and we'll put it into the equation number 2 again. And we'll get 5 plus 3y equals 11. Then we'll take 5 away from both sides, so we'll get 3y equals 11 minus 5, which gives us 3y equals 6. 3 is a common factor of 6, 3 will go into 3 and 6, divide through by 3, and y equals 2. We have our solutions once again, and they're the same solutions. So it really didn't matter which of the variables we eliminated first. X does equal 5 and y equals 2. The first solution we used when getting rid of the x's required us to subtract the x's one from the other. We refer to this as the subtractive solution. The second solution we used when getting rid of the y's required us to add the y's together. We call this the additive solution. You will be required to add or subtract x's or y's to solve for x and y, and you'll have to discover which is the best way to carry out the solution. Should you add or should you subtract? More often than not, you'll have choice, and you have to decide which is the easiest one to do, or indeed the quickest way. Now we're going to turn to exercise 7.2 on page 122, and we're going to solve some of these problems using the algebraic method. We'll try some of these together and then we'll throw them open to you for practice. But remember, write out all of the stages of your solutions clearly. Show you're working. So we're going to have a go at some of the problems shown in exercise 7.2 on page 122 in your textbook, and we'll be solving using the algebraic method. So let's have a look at question 1. We've got 4x plus 2y equals 22, and we've got 3x, I think it's minus 2y, equals 6. So if we quickly look at these two equations, we can see that the y has got the same coefficient 2 in front of each one. Now one is a plus 2y and one is the negative 2y. So this leads us to think about using the additive method for solving this algebraically. So we'll call this one equation 1 and we'll call this one equation 2. I'm going to add equation 1 to equation 2 both sides. So look at the left hand side. We're going to get 4x plus 3x will give us 7x. A 2y and a negative 2y will knock each other out, so we'll get no y. And on the right hand side we're going to get 22 plus 6, which will give me 28. Well, there's a common factor here. 7 goes into 28 4 times, so divide both sides by 7 and x will equal 4. So we've now got the first part of our solution. We can now substitute the x into either one of these two equations, whichever is easiest for you. I'm going to take equation 1 just because it happens to be the first one, but equation 2 might be easier. Let's put x equals 4 into equation 1. So we'll get 4 multiplied by 4 plus 2y equals 22. In other words, 16 plus 2y equals 22. Now we'll subtract 16 from both sides, so we get 2y equals, the 16 take away 16 will knock out that 16, 22 take away 16, or 2y equals 6. Divide both sides by 2 and y will equal 3. So we've got our two solutions then, x equals 4 and y equals 3. So let's have a look at question 3. Now again we're going to use the additive method for this algebraic solution. We've got two equations, 5x minus y equals 9, 3x plus 2y equals 8. And close inspection again, we note that the y's are very close to each other. We've got 2y and a y. It wouldn't take much to get this minus y to be a minus 2y. So if we label that equation 1 and label that equation 2, what we'll do is we'll multiply equation 1 throughout by 2. So we'll get 2 times 5x is 10x, 2 lots of minus y is minus 2y, and then 2 lots of 9 gives me 18. We'll call that equation 3. Now, because I've got a plus 2y above here on question 2 and a minus 2y on 3, if we add 2 and 3 together, we should be able to knock out the y's. So we're going to add 2 and 3. By that I mean equation 2 and equation 3. Let's do the left hand side of equation 2 and 3. 3x plus 10x will give me 13x. Plus 2y minus 2y, knock each other out, will equal 8 plus 18 will give me 26. If I divide both sides by 13, because 13 is a factor of 26, I'll get x is equal to 2. 13 goes to 26 2 times. Now let's substitute the value for x. And we'll substitute that into, well, why don't we take equation 2 again? It's fairly straightforward. So into 2. So 3x will be 3 times 2 plus 2y equals 8. 3 times 2 is 6 plus 2y equals 8. So now let's get rid of the 6. We'll take 6 away from both sides and we'll get 2y equals 8. Take away 6 will give me 2. 6 from 6 will knock out the 6. 2y equals 2. We can guess what y is, can't we? Divide both sides by 2 and y equals 1. So we've got both of our solutions again. Now let's try question 9. This is one where we need to use subtraction instead of addition to get rid of either the x or the y. Now again, looking at my two equations, let's label them up again. Equation 1, equation 2. X and x are very close. I've got a 2x and a single x here. So what I might try and do here is multiply the bottom equation, equation 2, throughout by 2. Let's just do that. So we get 2x plus 6y equals 26. We'll call that equation 3. Now I'd like to take either 1 away from 3 or 3 away from 1. Since this has got 6y and that's y, so this is bigger, and this is 26 and that's 6 and 26 is bigger, I'm going to take 1 away from 3. So let's look at the left hand side first then. 2x take away 2x, knock each other out. 6y take away y, I'm left with 5y. 26 take away 6, I'm left with 20. Now, 5 is a factor of 20. 5 will go into 24 times, so we'll divide both sides by 5, and I get y equals 4. And there's my first part of my solution. So now I'm going to substitute the value for 4 into one of these two equations. I'm going to take the easiest one, just 1x here. I'm going to take equation 2 again. and we'll get x plus 3y, that's 12, equals 13. So x plus 12 equals 13. I think that's pretty straightforward, isn't it? Something plus 12 is 13, that something must be 1. So we got our two solutions again, y equals 4 and x equals 1. Now we'll try something a little bit more challenging. Question 31 on page 123. This one is more challenging because there's no simple just multiply by one number through one of the equations to make the x or the y's match up. We're going to have to work equation 1 and equation 2 to get something to match. Now we need to consider the numbers in front of the x's and the y's and ask ourselves, is there a number that these values will both go into? In other words, they're factors of that number. So for example, if we take 3 and 4 for the y, 3 and 4, what number could we think of that 3 and 4 would go into in the smallest possible number? And I think you'd probably come up with the answer 12. 3 goes into 12 4 times, 4 goes into 12 3 times. If we look at the values in front of the y, we've got a 5 and we've got a 7. What's the smallest number we can think of, a multiplier, that 5 and 7 will go into? And again, not too much work done to realise it's probably 35. Now I think I'd rather work with the 12 than the 35, it's a smaller number. So I'm going to multiply the top row, the top equation, by 4 to get this 3 to be 12. I'm going to multiply the second equation by 3 to get this 4 to be 12. Let's have a go at that then. So equation 1, we're going to multiply by 4. 4 times 5x is 20x minus 12y equals 4 times 34. 4 4s are 16, 4 3s are 12, plus 1 is 13. We get 136. We'll call that equation 3. I'm now going to multiply the second equation by 3 to get this 4 to be 12. So 3 7s is 21, 21x minus 12y equals 3 lots of 47. 3 7s are 21, carry 2, 3 4s are 12, plus 2 is 14. I'll call that equation 4. So now I can take one of these away from the other and just be left with the x. Now do I take 3 away from 4 or 4 away from 3? Well, the 21 is bigger than the 20 and the 141 is bigger than the 136. So I'm going to subtract 3 from 4. So 21, take away 20, I get x equals 141 minus 136. 141 minus 136 is 5. So that's my first solution, x equals 5. Now, let's substitute that back into either equation 1 or 2. I won't use 3 and 4 because they're much bigger numbers now I've multiplied through. I'd rather use either 1 or 2. I think the easiest one probably for us to do would be the 5x. So I'll take equation 1 and we'll substitute x equals 5 into 1. Let's do that then. So we're going to have 5x is going to be 25, and then we're going to take the minus 3y equals 34. Now I could take the 3y to this side and 34 to the other side to try and get rid of this negative. I'm going to multiply throughout by minus 1. So I'm going to get minus 25 plus 3y equals minus 34. Now I'm going to get rid of the 25 by adding 25. So I'm going to get 3y equals the 25 and the minus 25 knock each other out, and 25 and 34, well, a plus 25 and a minus 34 will give me a minus 9. And then I can quickly show by dividing both sides by 3 that y equals minus 3. So I've got my second solution. X equals 5, y equals minus 3. In this case I've used the subtractive means of working out algebraically how to solve the simultaneous equation. Now it's your turn to have a go at some of these questions, test your understanding, and then check your answers at the very end. This is questions 1 to 16, and these will be followed by 17 to 32. and the answers are at the very end of this presentation. So at any point you can stop the presentation and check your answers by looking at the very end. So now the answers are here. Good luck everyone. I hope you have great success with exercise 7.2.